Lesson 4.6, Similarity and Transformations. Essential question: when a figure is translated, reflected, rotated, or dilated in the plane, is the image always similar to the original figure? So what is similarity transformation? Well, a similarity transformation is a dilation or a composition of rigid motions and dilation. So if you can perform these things and get one figure to map onto another, we call that similar figures. So here's a definition: similar figures if and only if there is a similarity transformation that maps one of the figures onto the other. Okay, similar figures have the same shape but not necessarily the same size. The only way they would have the same size if the scale factor were equal to 1 or -1. If the scale factor is different, then they'd have different sizes. All right, let's take a look at a problem where we use similarity transformations. In this case, we're using a translation and a dilation. Remember, as long as we use a combination of those kinds of similarity transformations, then it is called a similarity transformation. All right, so we're going to take these points and we're going to do a translation. So that's going to be adding 5, that'll be 1, adding 1 here, that's 2, adding 5, that'll be 3, adding 1, that'll be 3, adding 5, that'll be 3, and then adding 1, that'll be 2. And I have the original or the pre-image, and now I'm going to graph 1 up to 3, 3, and then 3, 2. So here is the triangle after a translation, and that looks right. Okay, now let me change the color, and now we're going to perform a second transformation. In this case, it's a dilation. So a double prime, we're going to take these two numbers and we're going to times them by 2, 2, 4. B prime is 6, 6, and C double prime is going to be 6, 4. Let's go ahead and graph that. So 2 up 4, and then 6, and then 6, and then 6, 4 right here. And so this blue one is the final image after going through 2 similarity transformations. And we say that this triangle is similar to this triangle because it's undergone a sequence of similarity transformations. Okay, let's take a look at this problem. We're going to do much the same thing. Rotating 90 degrees about the origin, I think what I'm going to do is I'm going to write the rule, and the rule is x comma y maps to opposite of y comma x. So I'm going to find the image. So this is C prime, and that's going to be -2 comma -2, and then D prime is going to be -2 and then 2. Now I'm going to go straight into my next transformation. I'm not going to plot this. I'm just going to go straight into this one. I'm going to take half, so C double prime, and it's going to be -1, -1, and D double prime, and that's going to be -1, 1. So let's go ahead and graph this. -1, -1, and then -1 up 1. So this is now C double prime, and this is D double prime. Okay, so what we have seen happen is we've seen it go through a rotation, so it's turned, and then after it's turned, it's going through a reduction, and so that's the outcome. All right, let's take a look at this. And this is where I give you the picture, and you have to figure out what the similarity transformations are. Well, we can see one of them is going to be a reduction because we're starting with this trapezoid and we're going to this one. So I want to reduce, and let's see if we can figure out what we reduce by. Let's compare PQ. Here's PQ, which is 3 long, and I'm going to compare it to, here's PQ, I'm going to compare it to WX, and wx here is 1. So I'm going for something like that's a length of 3 to something that's 1, so I can see that my reduction is 1/3 x and 1/3 y. Okay, so let's go ahead and I'm going to take each point and I'm going to times it each by 1/3. So here's p, and p is -6, 3, and when I reduce it, it's going to be -2, 1, and then I have q, and that's going to be -3, 3, and then timesing by 1/3, it's -1, 1, and then r is 0, -3, so r prime will be 0, -1, and then s is -6, -3, and that'll become s prime -2, -1. Let's go ahead and plot these. -2 up 1, -1 up 1, 0, -1, and -2, -1. Okay, so here is the image through the first transformation here. Now, it still isn't mapped onto the figure, but you can see it's going to be a reflection. So the next thing that I want to do is, after performing the dilation, I want to do a reflection across the y-axis, so that's going to require this. And when I run this transformation into this, then I should be able to get the mapping. And so if I go ahead and operate there, I should be able to get 2, 1, and 2, 1 is W. Okay, when I do this reflection, I am going to get 1, 1, and 1, 1 is our X. And I'm going to do it again. This is going to be 0, -1, 0, -1 is my Y, and then I'm going to go 2, -1, and 2, -1 is my Z. So I have performed these two transformations, and they're part of the list of similarity transformations, and I got PQRS to map onto this. Okay, your turn. Please stop the screencast and see if you can try to find a sequence of similarity transformations that'll map DEFG to STUV. Stop the screencast. Okay, here's the answer. This is one possibility, and one possibility is to do a dilation on DEFG twice, half as much. And when I do half, I showed you the picture of what it looks like half as much. And then this looks like it's a rotation, 180-degree rotation. And so I think it's this. So I went ahead and went through the points and did the half, and then did the rotation, and sure enough, it matched to points S, T, U, and V. Okay, how can we prove a square ABCD is similar to another square? And so I have this square right here, and what I'm going to do is I am going to translate, I'm going to translate this over to here. So the first thing I'm going to do is, let me get my pen here, I'm going to translate A, B, C, D along vector AE. So I'm going to make this my, right here, how I'm going to move it, so that angle A maps to angle E. So I want angle A to map to angle E. So I've gone through a translation. Now afterwards I want to dilate. So I want to dilate the figure that's been translated, dilate by a scale factor. And it looks like I want to, my new measurement is S, my old measurement of my side is R, so I want to dilate by K equals S over R. So by a sequence of similarity transformations square ABCD maps to square EFGH. And when that happens, when you get this sequence of similarity transformations, then you know you have similar figures. All right, go ahead and you try this. You try to prove that the triangle is similar to the other triangle. Stop the screencast and see what you can do. And here's my answer. Translate triangle JKL along vector LP so that angle L maps to angle P. You want to move that triangle and then dilate the triangle with a scale factor of new over old. And so these triangles map to each other by a sequence of similarity transformations. And this is the end of the screencast.